Welcome back. This is our third section on the National Weather Service Spokane's virtual spotter training, and this section is about Severe Weather 101, the inland northwest style. Well, first of all, we're going to start out about thunderstorms. And what is a severe thunderstorm? Well, severe thunderstorms have a specific criteria. First of all, you will need to have winds that are 58 miles an hour or greater. These cause considerable damage. Or hail that's at least 1 inch in diameter, which is the diameter of a quarter or greater. Now there's different ways to understand the severe thunderstorm risk. We have an office, the Severe Storms Forecast Center, that's in Norman, Oklahoma. They look over the chances of severe weather across the entire country. And they will put out maps daily that recognizes areas that need to be watched for severe thunderstorm development. There are different colors and criteria that they use to try to express that level of severe weather to the public. It ranges from general thunderstorms to marginal risk of severe weather to a slight chance of severe weather to a level 3, which is enhanced, where we could see numerous severe thunderstorms, to a level 4 for a moderate risk, and then 5 is a high risk, where you can expect widespread severe weather and tornadoes. These maps can be found online at spc.noaa.gov, and they're done for day 1, 2, and 3 and shows the chances of severe weather across the country. So the National Weather Service has their own types of terminology to describe different types of weather hazards. We start out looking at the weather hazards out on day 5, 6, and 7. And when it looks like that there is the potential for any type of severe hazardous weather, we'll put out an outlook to let people know that there is a general idea that we could see some hazardous weather. Now, when the forecast is coming in line a little better and we have better confidence that there's going to be some severe weather or hazardous weather, we'll put out a weather watch. This usually comes out between 24 to 48 hours in advance. And what it describes that our conditions are favorable but not imminent for severe weather. Now, as we get closer to the event and it looks likely that there's going to be severe weather, we will issue a warning. And the warning means that severe weather is imminent or will be occurring, and this can come out as early as 12 to 24 hours in advance. For more short fuse types of conditions for severe thunderstorms, the warnings may be out an hour or less before the event strikes. Now, advisories are a different type of term. They do describe when weather is occurring now or expected in the near future, but it describes more inconvenient or nuisance weather that most likely aren't going to be life-threatening. So the difference between a watch and a warning means a watch, when conditions are favorable for severe weather, it means it's time for you to prepare, to monitor the forecast, monitor the skies, to be ready. A warning means that severe weather has been reported in your area or it's likely to happen and it's time to act now. Now back to thunderstorms. All thunderstorms produce thunder and lightning. They can produce rain, hail, wind, and even tornadoes. For thunderstorms to develop, you need 3 main ingredients, and this includes moisture, instability, and lift. So for our area in the inland Northwest, we have several sources of moisture. Most of them come from the Pacific somehow. One, it would be from an upper level low pressure area that's over the eastern Pacific that would bring some unstable and moisture from the Pacific inland. Another source would be coming from the south with a subtropical jet that streams northward and brings up that moisture. And another source would be from the monsoons over the southwest United States that would bring moisture up from Baja, Mexico, northward. Instability, that just means how stable or unstable the atmosphere is. For a stable environment, this is when you have cold air at the surface and warm air above. The cold air wants to stay where it is, while the warm air is less dense and wants to rise. We typically have this type of environment in the wintertime when we have our gloomy days of low clouds and fog. But during the spring and summer times, we can get unstable conditions where the surface heats up from the sun and we get colder air aloft. When this happens, the air wants to mix, and this mixing increases the instability. So here's some examples that show different environments of stability. Under a stable environment, you'll get the air that will flow right over the mountain and straight back down again. Under an unstable environment, when you have air flowing over a mountain, it will keep on going and develop cumulus clouds and possible convection. So the more unstable the atmosphere is, the better chance for thunderstorms. Now lift. For storms to develop, we need a way to lift those air parcels up in the atmosphere that's unstable and full of moisture to produce the thunderstorms. So lift can come from many different sources. One common form is from a cold front, where you get a boundary of colder and more dense air that pushes into an area of warm air. The air converges along this boundary and forces it to rise and produces cumulus clouds and thunderstorms. We can also get lift from mountains. When air rises up the windward side of the mountains, and that rising of the air makes the clouds. We can get showers and thunderstorms that develop on that side as well. Now with thunderstorms, there are 3 distinct stages of thunderstorms. The first stage is the towering cumulus stage. That's when you get the cumulus cloud that is forming and building. It's dominated mostly by updrafts. As the cloud develops more, it moves into the mature stage. And that's when you get the updraft continuing, but then the downdraft also starting. This is when the storm would be at its peak height and development. Then over time, the downdraft will take over and wipes out the updraft. The storm then begins to dissipate and dominated mostly by wind and precipitation. This type of pattern describes your general garden variety thunderstorm, which usually lasts about 30 minutes and can bring brief periods of heavy rain, maybe some small hail, and gusty winds. But thunderstorms can also range in scale on development. Sometimes we can get thunderstorms that develop along a line, multicellular thunderstorms that have storms along the line at different stages of development. These types of storms last longer, are a little more structured, and can provide a longer period of severe weather. We can also have more structure in a thunderstorm, and this would be called the supercell. supercell thunderstorms do develop in the inland northwest. Likewise, they're found all across the country. They have more structure because the updraft and the downdraft are tilted in the storm. This allows the storm to last longer, and the updraft never really gets cut off, so allows the storm to continue to produce periods of severe weather. What makes this structure a little bit different is the wind shear in the atmosphere, or the difference in winds changing with speed and direction with height. And this causes the storm to be tilted. And this tilting allows the storm to continue to propagate and persist for hours at a time. These types of storms also produce the most type of severe weather with periods of large hail, strong damaging winds, and tornadoes. So for a supercell, we need wind shear through the atmosphere in both speed and direction changing with height. This tilts the updraft and the downdraft and causes the storm to last longer. And with that, we can get some very strong wind draft speeds of up to 100 miles an hour. Also with supercells, they tend to rotate and spin. And this spinning helps create the rotation that helps for the development of tornadoes. And here's an example of a supercell that was spotted right outside the Weather Service office in Spokane just a couple years ago. Wind damage is on the spotter checklist, and it's also an important factor to report as a weather spotter. We like to hear spotter reports of wind damage, of any reports that are 30 to 40 miles an hour or greater. Winds that produce any type of damage. And keep in mind that severe winds are 58 miles an hour or greater. Now, as a weather spotter, you don't really need weather instruments to gather this data. There is a scale called the Beaufort scale that allows you to estimate wind speeds by looking at trees in your yard or flags on flagpoles, and allows you to describe how they're moving to estimate what the wind speeds are doing. Sometimes with strong winds, we can get the downdrafts from the storms creating microbursts or straight line winds. This is when the downdraft or precipitation drags down and drops rapidly to the surface. The evaporation can cool the air parcels in the storm and causing them to become heavier and more dense. This increases the acceleration and brings some very strong winds to the surface. Sometimes they're very hard to spot because there's not a lot of clouds to detect them. And we do know that anybody who's flying or who's a pilot knows to stay away from thunderstorms for this reason, for these strong downdraft winds that come down to the surface. Now there's different things to spot on storms that give you an idea what part of the storm you're looking at. In this example, we're looking at the front end of the storm where it looks like a shelf. And what this is indicating are the edge of the downdraft of the storm and the arrival of strong gusty winds from the downdraft of the storm. Shelf clouds do portray a shelf on the edge of the storm and indicate strong gusty winds. Here's an example of some straight line gusty winds that happened at the Weather Service office in Spokane. And you can see how it's whipping the trees and the flagpoles coming across the parking lot. Sometimes some strong winds can move objects to strange locations or topple tall trees and power lines. And most people in the inland Northwest remember this happened not too long ago with our windstorm that happened back in November 17th of 2015. Now this type of storm was a more winter type storm. It was more of a synoptic scale storm, but it did show the strength of winds and what type of wind damage that can occur. This was the strongest winds that Spokane has seen, from a windstorm with up to 71 miles an hour. Hail is another item on our spotter checklist. Hail are balls of solid ice that form in strong thunderstorms, and they're layered in ice as the ice pellet rotates through the thunderstorm. Now, the example at the bottom of the page shows some of the biggest ice that's been reported in our region over the past several years, and that shows about 2.5 inches in diameter. So hail forms in the updraft of the storm. Strong updrafts keep large chunks of ice aloft. The stronger the updraft, the bigger the hail. The hail tends to fall in the downdraft, but then circulates back up to the updraft, collecting different layers of ice on the ice ball. And large hail can produce some damage to windows and siding. Here's a depiction of how hail is formed, starting from small supercooled droplets that freeze in the upper portions of the storm. As they fall down, they rotate back up again from the strong updraft in the storm. So, for those who like weather trivia, the largest hail size ever reported happened in South Dakota back in 2010. It was 7.9 inches in diameter and weighed almost 2 pounds. And here's on the bottom the picture of some of the largest hail reported in Julietta, Idaho back in 2012. And here are different ways to describe how big hail is. We start out with coins. Penny size, quarter size is considered severe, and up to $half size, and you can use balls like golf balls or pool balls, even baseballs too. Now tornadoes. Yes, we do see tornadoes in the inland Northwest. We see on average maybe 3 to 5 a year. They're very small, last on the ground for 5 minutes, if that, can be up to 100 yards in diameter, with wind speeds 85 to 115 miles per hour. Here is a picture of a tornado that happened just last year in 2016 in Airway Heights. And another image of a tornado that happened in Douglas County last summer as well. So as I talked about with supercells, they tend to rotate. And that rotation in the storm forms the mesocyclone. The mesocyclone is what we can detect with our Doppler radars. It's that rotation in the storm. Not all rotating storms produce tornadoes, but there's a better likelihood that we'll see them from these types of storms. Within that rotation of the storm between the updraft and the downdraft, we'll have a lowering of the cloud. This is called the wall cloud of the storm. And it's within this wall cloud that we would see any funnel clouds or tornadoes develop. Here's an example of a mesocyclone of a storm that was happening over the Spokane Valley. And here's an example of tornadoes that happened just several years ago across the Lincoln County. These were twin tornadoes. Tornadoes are measured on a scale called the Enhanced Fujita scale. They're measured after they happen by looking at storm damage and determining what type of wind speed occurred with them. Typically in our area we see EF0s, EF1s. They can go up to EF5s, and typically those are found in our tornado alley of the country from Texas, Oklahoma, and up to Kansas. We also see different types of tornadoes called non-supercell tornadoes. These can form from a boundary at the surface, causing an eddy, typically over a field where we get some dust devils developing from the uneven heating at the surface that causes the spin. And these boundaries or eddies are strong enough that they can be pulled in the vertical beneath a building cumulus cloud. The stretching of the column causes the air to spin faster, and we can get some small tornadoes to develop from this. Funnel clouds would be tornadoes that are not reaching the ground. So it's very important as a weather spotter, if you see what looks like a tornado or a funnel cloud, you need to look near the surface to look for any type of debris that's being picked up off the ground. If you don't see that and you don't see the column reaching the ground, it would be coined a funnel cloud, not a tornado. Now, Graupel. Graupel is a term that we've been hearing a lot about in the last several years. Typically, our Graupel season is late winter into the early spring, and it happens when we have convective clouds that develop showers when the atmosphere is still below freezing. So instead of rain that's rotating through, we get snow crystals that encounter the supercooled water droplets. And the water droplets freeze on the surface and kind of cause a riming to that snow. Graupel is referred to as soft hail, and it bounces when it falls, and it kind of is soft and looks like styrofoam. Graupel can grow in size, and you can get it to be as large as a penny to even a quarter at times. But keep in mind, this is not the severe type of hail that could produce the damage. This is more of your snow soft hail. And here's a picture of a Graupel shower taking place in the early spring. Now back to our spotter checklist. Heavy rain is very important to report. We like to describe rain in two different forms. Your more convective rain coming from showers and thunderstorms. If you get about a half an inch in less than an hour, that's important to report. Now, if you get your long duration of rain that happens overnight or through the day, if you get an inch of rain from that lasts in 12 hours, we like to know about that. Also, if you get maybe an inch and a half or more in a 24-hour period, that is important to report. Now, too much rain can cause flash flooding and even debris flows, where you get mud and rock that falls from the slopes. Flash flooding does occur in our area from heavy downpours and can cause issues on roadways. It's very important to remember you do not want to drive through a flooded roadway. It's better to turn around and don't drown. And here is a video that shows just this. As we see a semi that's going across a flooded roadway. The driver thinks he can get across safely, but sometimes you don't quite know what is happening to the road beneath the water surface or how deep it is. And in this case, this driver found out the hard way and saw how his truck had fallen into the water, completely submerged. Other hazards that we have to contend with in our area would be dust storms, especially if we have a period with not a lot of rainfall and we get strong thunderstorms with gusty outflow winds that will pick up the dust and dirt and send it miles away. Sometimes we can see the dust on satellite as a line, a gray line moving through an area, or even on the radar as well, where we see lines of dust and dirt moving from thunderstorms. They can be very difficult to detect unless they're close to the radar. And with these dust storms, they can produce poor visibility. So it's very important if you encounter anything like this and you're in your vehicle to pull over and wait for the dust storm to pass. Another hazard that is important to be safe about is lightning. As I mentioned, all thunderstorms produce thunder and lightning. Thunder is what you hear and lightning is what you see. And how lightning forms has to do with the strength of the cloud and the thunderstorm. The faster, the more rapidly it develops, the more you'll get charges in the storm that will separate. You'll get negative charges at the bottom of the storm and positive charges at the top. And charges like to attract. They don't like to be separated too long. And when they do attract and meet, this is when the discharge happens. And sometimes we can get strikes from the tops of the storms as well. And these can be even more dangerous because they can happen miles away from the parent storm. So it's very important to know as weather spotters to be safe. And when you do hear thunder or see lightning, to go to a safe shelter and wait out the storm. So weather spotter safety, your personal safety is your number one priority. Please be aware of what the weather is doing. Communicate with others where you are, what you're doing. Know an escape route if you happen to be in a hazardous weather environment, and know a safe place to go. Be very careful at night because it's hard to see weather hazards. And never put yourself in harm's way. Don't drive through flooded roadways. Don't travel through downed power lines. And if objects or structures are falling or are weakened from storms, please don't be too close to them. And stay current on the weather. Now this concludes this section of the virtual spotter training from the National Weather Service in Spokane. And I hope you can check back for our next session.